Hey guys, I hope you all are doing good. In today's video, I am in conversation with architect Mangesh Kurund. He has completed his masters from Bartlett School of Architecture, and that's in UK. And he has done a very unique degree. It's called Bio-Integrated Design. Before this conversation, I had zero idea about this particular course. This is not a typical biomimicry based course or a computational design course. This is something really, really out of the box, which deals with biology and architecture together. In this conversation, we will be discussing everything about this particular course, from entry requirements to the fees to what this course actually is about, what are the industry requirements, what are the industry demands, where you can get placed, and everything about this particular course. So, guys, without any delays, let's get started with the video. Thank you for coming on this podcast on such short notice. And thank you, Gulshan sir, also, who shared your story. And I was like, okay, yeah, this course seems interesting. So tell me your story, like how and why and what's your background?
Yeah. Hi, Saransh. Thank you so much for inviting me to your podcast. And again, thank you, Gulshan sir, for the reference. So, yeah, I mean, it's a long story, but basically, my background is in architecture. I did my BArch from Pillai Chosi College of Architecture, Rasaini. And the overall approach towards more of something like bio integrated design was a realization after my thesis. So yeah, I mean, my background basically has been a more of a focus towards design and architecture altogether.
Okay, so basically you wanted to go deep into the design field, something that relates more into design.
Yeah, absolutely. So I've always been very passionate for design. It's not just about uh, it's not just about creating something, but understanding through the process
Mhm.
what and how and why is it something needed in order to simplify our surroundings or maybe to make it more efficient. So yeah, this always has been a challenge, and then I gradually started taking the design towards somewhat bigger volumes, and then I got to know something about architecture. That was like long back after my high school. And then architecture was like I was truly passionate towards it, and that's how my background like kind of is revolving always around volumes and something that talks about uh, more of like inclination towards nature. So yeah, I mean, altogether it's always revolving around a design story.
Okay, that sounds interesting. Um, why did you choose UK and this particular university and no other? Like, what was your motivation and what guided you towards this?
Right. Here is something. Yeah, this is one question that I'm always my inbox is filled with. So it's a long story actually, but how and I'll share a complete honest path that I went through.
Mm-hmm.
So my bachelor's thesis was an agro fulcrum for farmers at Marathwada, which incorporated like 11 different types of structures, and the approach was always towards sustainability. Uh, and how do we make a healthy architecture? When I say healthy architecture, I mean how do we incorporate more of nature? How do we incorporate more of oxygenated environment? Because that's the final agenda, that how can we live in an environment which is more healthy for our co-living.
Yeah.
So I my approach was that. And so then I had a discussion with my mom that why don't we create, why don't we create bricks that already have seeds in it, like, and then eventually plants grow from the bricks. And then what we have is the vegetation that completely encompasses the building, and what we get is a nature coming out of the building over the period of time.
Mm-hmm.
And that was the first thought when I just randomly came across this approach of why don't we just integrate nature into architecture, like completely integrating with it.
Mm-hmm.
And then my mom was like, yeah, I mean, but your roots, the roots of the seeds are going to destroy your bricks eventually. And what you're going to end up in a house is completely roots and no, there's no bricks left. So, and then I was like, but yeah, why don't you look at another way around? So this was a kind of a conversation a very active conversation that was I was having with my mom and me. And she's not from architecture at all. Like she has a completely a very layman's perspective to it, but a very practical one. And the design in me was like asking her that why don't the roots take over the brick, eventually, and let the brick fade away. So all we get is the roots on the building. And it's like, yeah, that's a good approach. I think you should start researching, or maybe you should have more research towards it before coming towards the final narrative of like that.
Mm-hmm.
Then I was like, yeah, sure. And then I started hunting, or maybe more of like surfing on internet, that are there any types of courses that can actually teach me this,
Okay.
the thought that I have. And you wouldn't believe, I had no like I didn't realize that I want to do my masters from Bartlett, or I didn't realize that I want to do it from UK. There was one research question, and there was one thought that this is something that I want to do. How do I approach it?
Okay.
And I searched bio integrated, because that's exactly what I wanted to do.
Mm-hmm.
And the first thing that came across was bio IT, bio integrated design.
Okay.
And that's the relationship I got, that this is the course that I want to do. And then I went to my school, I mean the architectural college, Pillai. And then there was this professor called Dr. Joydeep Datta, named
Mm-hmm.
Dr. Joydeep Datta, and he's also my mentor. And then I asked him that, so this is the thing that I want to do, what's your approach towards it, and what do you think about it? And then he's like, Mangesh, what you have done, the series of sketches, is something that is called a statement of purpose that you need when you're applying to different colleges.
Right.
And I was like, oh, and I had no clue about this. And then he's like, yeah, so this is something that you want to write, convert your sketches into writing, and just make an application.
Mm-hmm.
And that was the moment of realization that, okay, this is something getting more clearer and practical. So most of the students write an SOP to fulfill their desire, to get into the course. But actually it's an approach to give you a clarity about this is what you should do, or this is what you want to do. Yeah.
Mm-hmm.
So in my opinion, I would call a statement of purpose to be a paper of clarity. So every individual must write on a piece of paper that what he or she wants to do, what is it that they are planning or aiming for,
Mm-hmm.
and where do they see themselves after a period of 5 or 6 years
Yeah.
after doing this. So that's a very clear approach.
Mm-hmm.
And when you write that, then you realize and question yourself that, okay, this is what I want to do, and this is where I'm heading towards. So that became my statement of purpose eventually. And it was not advised to me that you should incorporate a sketch, but I decided that my statement of purpose should have an architectural sketch below it that could be
Mm-hmm.
schematic, but that just explains my thought process altogether.
Okay.
So I ended up writing an SOP like that.
I would like to see that sketch actually. Send it to me later on.
Yeah, sure,
Like people
definitely,
also
definitely.
see it like, okay, like this is also a good approach to have. Like
Yeah,
I
yeah,
have never heard that someone has sketched on their SOP. That's
yeah,
a good idea actually.
yeah.
My next question is like, what are the requirements? Like, how does Bartlett select for this particular course? Like, do you have to have certain kind of CGPA, and like what all documents are required? Just an overview, like short overview.
Yeah. So Bartlett is definitely a very competitive place to get in.
Mm-hmm.
Currently, it holds the first QS World ranking,
Hmm.
and there's always a tussle between the three universities: TU Delft, MIT, and Bartlett,
Hmm.
for built environment. So definitely, it's competitive. Specifically to biointegrated design or Bartlett in general, I think you need to have a higher scorecard with the CGPA.
Hmm.
uh, I had 8.75 in my bachelor's,
Okay.
and I think somewhere above 75% is what they look usually.
Yeah.
but the closing criteria again depends on course to course.
Mm-hmm.
Another thing is the eligibility criteria is with respect to the the discipline you come from. Like, is it so? For example, if you're approaching towards a course like interdisciplinary course like bio integrated design, you would want a background somewhere in sciences, or somewhere in design, somewhere in architecture, somewhere in materials. Like that kind of aligns to the philosophy. So at
Yeah.
least one of the background you should be eligible so that you can get into it. I've seen students coming from a completely different corridor, but still been accepted based on the kind of an experience they hold.
Hmm.
So it absolutely depends course to
What
course.
are the other
Uh,
faculties that students have come from? Like, what does Bartlett expect? Like, you should be an architect, or you can be a civil engineer. Then also you can join this course. I don't.
yeah. Bartlett has an extraordinary courses, I would say. For example, I was a teaching assistant in my first year of MArch, where I was teaching as an assistant for a course called Masters in Engineering, MEng of Architecture. So
Okay.
it itself has engineering and architectural, course.
Hmm.
So it's not necessary that you have to be only in architecture. It could be an engineering student who decides to enroll into a design. So that again depends on
So this thing is open for other field as well.
yeah, absolutely.
Wow.
But again, the eligibility, as I'm again saying that it depends on course to course. For example, if you come from a law, like based on a law background, you would want to have something that is closer to it. So the eligibility criteria is clearly mentioned on the UCL website. And every student who texts me about these questions, or who tries to contact,
Mm-hmm.
every time I always mention them that it's first is the self research or the background research that you must do to get a clarity about the courses. And that is very much clearly given on the website of the UCL. So it again depends course to course.
Okay.
So it's important to understand that why this course was important, or why is it in existence. It's
Hmm.
because it questions the approach towards practice towards architecture. It
Okay.
questions the material palette of architecture. It
Mhm.
questions the technology that is needed to get indulged into architecture.
Mhm.
So in that exploration, BioID demands for students, which are in fact from different disciplines like biotechnology, material scientist, and all of that.
Mhm.
And you can still get enrolled into BioID, but then for that particular students, they get an enrollment through MSc.
Okay.
So there are two parts. There is an MArch and MSc that is provided by the Bartlett School of Architecture for the course of
Okay.
BioID. And you can, if you have that kind of discipline, you can come through MSc to
Okay.
do BioID if you are
Okay.
from a medical perspective. So I've
Mm-hmm.
seen my senior, I've seen few of my students, like few of my senior students
Hmm.
who has enrolled into BioID, who did not had who did not want to pursue architecture further. So they
Okay.
switched their lanes from architecture to MSc,
Wow.
and
Okay.
that was accepted. That was clearly accepted during an MR. So this also acts as a checkpoint
Hmm.
for architecture students if they want to switch the lanes and get into the path of sciences.
Okay.
And you can still do science
Hmm.
through architecture as an MR student. So that's something that I did during my MR.
Mm-hmm. And what were the subjects like? What were the things that you were taught in this course?
So
Like, give an overview.
basically,
Like, and you don't have to go in.
yeah,
Like, just an overview.
yeah. So basically, it has a very organic way to go ahead. I
Hmm.
would say it has three. It runs in three boosters, or maybe it runs into three core ideas of computational design.
Okay.
Then there is a more of like the materials that comes through the lab module, and then there is a fabrication module,
Okay.
which talks about how do we make things.
Hmm.
So these are the three segments that you go in.
Okay.
And the lab is more about science approach. Like you have scientific way of investigating, writing. You get a approach towards writing a paper. Then you completely into the discipline of academic sciences.
Yeah.
Uh, then in computational, you get more into a programmatic or maybe more of like a procedural modeling approach.
Yeah.
It's more of a programmed approach where you develop a lot of design through computational aid. And fabrication is more about utilizing 3D printing robots or 3D printers. Like you have a completely fabrication approach, of fabrication more of like towards laser cutting, CNC. So there's a lot of machines that are available that you can explore through fabrication. So this works in this whole fabric of
Hmm.
bioid works in these three important fibers, I would say, that are twinned together. So making subjects, I would say, is a very generic way of looking at it, but developing skills, for a certain narrative is what I would look at it at.
Yeah. You're right. And one more important question, like uh, when you enroll into this and when you are going through this course, what all are the softwares that you must know before joining this course, and what are the softwares that you will learn? Like, do you have any idea of that? Like, how a person can approach? Like, for example, I want to enroll into it. I have certain sets of skills, but would you say like I should know this software before joining, and I can learn later on, like other softwares while I'm doing this course?
Yeah. So the softwares that I learned beforehand, or maybe you have been expected to learn, is basic 3D modeling softwares,
Okay.
and you should have a presentation approach towards it. Then it also depends what background you're coming from. If you're coming from an MSc background, then definitely they expect you to have experience on scientific writing, literature review stays common in both the scenarios. Then the other way of looking at it is your skills towards like exploring a more of like with a scientific lens. You would want to have a questioning approach of developing research questions, that questioning something that is needed, so that again gets gel with literature review, and then you approach
Yeah.
towards questions. So you should have this kind of a background, I would say, or the kind of a skills uh, in prep before reaching towards something very like a focused goal in the course. So yeah, I mean, these are the things that you should have. Then a constant desire to experiment with things. It's not necessary that it always has to be with materials. Could be a computational experiment, it could be a fabrication based experiment. So it could be more of like that. Softwares, I would say Rhino, then rendering, some basic rendering softwares to present your initial ideas at least. Then I
Mhm.
think you should know a bit of video editing so that you could, uh, like, so that you can actually screen your ideas the way you
Yeah.
want to. That's, I think that's a very important skill to have, and I think it's very common these days to make a film of your work to present, and so that you get more reviews on it, or maybe more of the
Mhm.
public way of looking at it.
Yeah.
So that is one thing. Another is more of like an climate analysis tools. Could be plugins of Rhino, like
Mhm.
ladybug radiation analysis, something like that. These are the things you will be eventually taught as well, because
Yeah.
they don't expect you that every student from a different background should have this. So they eventually teach you this
No
through the course
programming or
modules.
anything is needed, right?
Not exactly. It doesn't say that you need a programming background.
Hmm.
But if you have it, it's always in great use in architecture these days, because it's more of like a powerful tool to have to analyze and compute your data, right? So that's good to have. Another thing is more of like people deal with parametric or procedural modeling softwares. I think this is something very helpful to have. Uh, Now, the softwares that I learned in BioID is completely depending on the type of work, but the basic software that we like we understand, we learn, or we communicate our ideas through is Houdini FX. This is one particular software that BioID focuses a lot on, because there are situations when you're dealing with biological specimens, to do
What is Houdini?
uh,
Like, I haven't worked with that software. What is
so it's a procedural modeling software.
okay?
It kind of helps you to generate simulations. It kind of helps you to generate animations. It's more of like a procedural way of designing.
Okay.
So for example, there are I'll share my work later on, but it's
Mhm.
more about how do we approach a computational wireframe, and how do we create, how do we model, but in a very procedural way, so
Mhm.
for example, in BioID we deal with organic matter, we deal with biological specimens, we deal with biology. And biology is very unpredictable, but it has nature has a very mathematical approach towards things, right?
Yeah.
So you talk about golden mean ratio and all of that, but the way it grows, it's beyond our control. It's
Mhm.
very uncontrolled thing, but it has a very iterative way of looking at it.
The
So
probabilities are
Houdini,
in infinite, like when it starts growing.
yeah, yeah,
Hmm.
exactly. So when you're dealing with something that grows,
Hmm.
then you start a conversation of expansion, then you start a conversation of colonization, then there is a conversation of shrinkage, all these kind of natural parameters that comes into picture. How do we deal with these parameters is what this software helps you to actually control your models. So for example, if I want to show that this pen maybe is covered with certain growth, first of all I need to address what is this growth. I need to set parameters of the growth. I need to understand that how, where do we want it so that it looks the way I want it as a designer. So this aesthetic control, this functional control of parameters that we set, what we call parametric software, and then
Yeah.
we gradually can iterate these things, is what we can learn from Houdini. So this is one thing that goes. And then we have other rendering softwares like Redshift that goes in complementary to Houdini,
Red
where
shift.
uh, Redshift, it's more of like a rendering software. So
Okay.
it goes complementary with Houdini, where where we can set properties the way we want it, of the materials or the things,
Hmm.
to exactly kind of bring up the idea of the thing that we want to design, or thing that we see after designing, how would it look like, more of like a realistic approach. And then you can also go ahead with Unreal Engine to make walkthroughs,
Hmm.
in contrary to what work or how the model is going to be in the city life or somewhere else. So these kind of things vary, like with based on what do you want to project to the people, or the conceptual idea that you have.
Hmm.
And why such softwares are important as well is because uh, when you set up an experiment, it's not necessary that the results will come on an expected date. Yeah.
Yeah.
And when I say about these things, I talk about materials, I talk about biological species you're dealing with to
Hmm.
design. So in that case, you need softwares that can actually animate this approach in order to fasten the idea of visualization. So you start with something showing that this is what has been done, and then you speculate through the computational design. Speculation comes forward that this is how I would want to, and this is how it would look like.
Before we further continue to this video, I would like to request all of you to go ahead, hit a like and subscribe to my channel. Still 80% of the viewers haven't subscribed to my channel, and this actually prevents this video from reaching the audiences. I'm taking all these efforts just for you guys. So go ahead, hit a like and subscribe to my channel, and let's continue with the video. Thank you. So basically, it's functioning on or like building up on the concept of biomimicry, right? Like this entire
So
course.
Yeah, so most of the times people have this notion that biointegrated design has to deal a lot with biomimicry, but that's not the case. It's actually different. It's so in biomimicry, you learn from biology, you learn from nature, you
Yeah.
get inspired from it, you try to mimic the function of how it's happening in nature,
Mhm.
and you try to comprehend that function into the fabric so-called architecture, or say any design product, anything. Yeah, biointegrated design is actually integrating the biology. It's
Hmm.
actually integrating the biology with design. So it does not just limit its function, but
Mhm.
in fact it kind of allows a complete integration of the specimen itself.
Yeah.
So when I'm talking about bio id, why that is, extraordinary, is because you are not limited to the boundaries of man-made materials. You have started inviting biological materials to fulfill what you
Yeah.
want to approach. Yeah.
Actually, I have seen some science fiction movies like where they have developed the entire architecture based on biology.
Yeah.
I think so. Recently, it was Guardians of Galaxy or something. There was a scene where they came across a civilization
Yes,
and
the Guardians of
had
Galaxy Part 3.
everything
Yeah.
made up of biology, like the
Absolutely,
crystals
absolutely.
and everything. I was like, okay, yeah, something like that, right?
Yeah.
I wish we could achieve
Absolutely.
that.
So sooner or later, yeah. I mean, that's the whole idea of biointegrated design.
Yeah,
That sooner or later we should reach this stage. But yeah, I mean, that's a world we
that's the
dream of
concept. Like
to.
you are integrating, you are using the live form of biology
Yes.
and
Yeah.
making.
Yeah.
You are not using getting inspired and using man-made materials to create something that looks like biology,
Yeah.
basically.
So exactly. And when you start a conversation,
Mhm.
to bring biology into design, you are dealing with time, which is one of the most important factor, and one of the most biggest challenge in this course is to develop this idea,
Yeah.
to prototype this idea, and to show that actually this is doing, the biology is
Yeah.
growing on it, and actually it's doing its job. It's merely it's very difficult, because it doesn't, things don't always
We
happen
can't
to what
accelerate
you
the
think of,
growth of
because
something.
sorry.
We can't accelerate the growth of something
Yes,
to prove that
exactly.
our concept works.
Yeah, so in that case what we have a powerful tool to still work on that approach is fabrication. So
Okay.
what you try to do is you try to have compatible materials, you try to have compatible tools,
Mm-hmm.
or compatible palettes of things that can go with the biology, in order to kind of complete or have a semi-living approach system, semi-living system approach. So if not it's completely living, you kind of provide a semi-living template to to fulfill the approach of a living in the coming time. Because time is a, I wouldn't say it's a barrier, I would say it's a timeline of things to get completed,
Yeah.
and you cannot control time. So what you would want to do is you would want to bring up situations that are more favorable for nature
Yeah. To
to
accelerate the growth.
expand, to colonize over the period of time. And that's something that's very important, which we never think of. We always design things for humans, but we neglect the fact of nature integrated environment.
Mm.
And currently in today's date, we live in like 2023, but currently what we have is like vertical walls, which are like just plants that are growing, which are vegetative, heavily vegetative.
Yeah. Which
But
is
still
actually
how.
not helpful at all. It just looks
Yeah,
good.
yeah, and it's very difficult. I wouldn't say it's not helpful at all, but I would say that it's very difficult to maintain. It's very difficult to maintain, and it
Exactly.
gets over. It gets completely neglected over the period of time. And whereas we have some very interesting species that are simpler, that are easier to apply, but we kind of shy away from it because it's not portrayed, or it's
Mhm.
always been ignored over the period of time, all these years, like mosses or algae or lichens.
Mm.
So these are like very interesting species, but what I see is the market has started evolving. Market has started adopting a lot of biomaterials. There are successful companies like Biome in London, which kind of deals with mycelium, which is fungi, and
Mhm.
they're trying to develop packaging materials. They're trying to have an approach of sound insulation panels, which is again developed with mycelium.
Yeah.
So that's again nature based. So these kind of more of like a product approach is very much appreciated in the industry. When it comes to architecture, dealing a complete building, it's kind of very much difficult and challenging at the moment. This is something that the academians are trying to do, but it's going to take time for the industry to accept, because it's always in a reach, always in a timeline of getting that maturity, or and it's got going to take time. Any tech takes time. So that is one thing. But the career prospectus, if you ask me, I think it's more about the use of the uh, environment analysis tools or environmental data driven design approach
Mhm.
is very much easily accepted in companies to have candidates that know that skills, which you kind of end up learning through BioID, because you want to answer the growth, or you want to answer your design, how is it successful with respect to environmental parameters. So that deals with solar radiation analysis, that deals with moisture retention, that talks about multiple other parameters.
Yeah.
So the kind of seniors that I had a conversation with, who's currently in Foster's for sustainability team. Someone is in Zaha, so they were who's doing more of like a computational design. So most of the students get selected is who are into computational, has a very strong hand on computational approach.
Yeah.
People who are into more of like materials are starting their own startup, or getting more into materials or sciences, are more into towards
Developing products.
lab. Yeah. Developing the further research or getting into academies, or maybe also acting as research assistants. And that's a story for all the three skill sets, I would say. It's not like one, but majority of the companies prefer computational design skill sets. And if you have an extraordinary work experience, I think it's not necessary that only people like that can be chosen for a computational aspect. It could be also for material, design. It could, like, there are different types of opportunities in different companies. And
Depends on
now,
the requirement also, I feel like,
yeah, exactly.
plus to the students, I keep always saying this, and I hope you guys also will understand this. Like, always think from the perspective that you own that firm, and what skills would you need, or what skills you would ask from a master's graduate person. Like, okay, fine, I want him to know computational design, I want him to know this, because it's like checkbox for them. They are not there
Yeah,
purely for design. Like, to be very frank, not every firm or not every company functions purely on design. You have to see, like, because we are like moving parts basically in that company. We need
yeah,
to
yeah,
see what we can give to them. Okay, design and
yeah.
everything is a factor, but there should be a skill set that they can use.
Yes,
So
yes.
that is something
So
that you should also focus on. What will give you that kind of skills? Like, he is talking about computational design, and people are being picked up with such big firms because of that skill. So you have to think and like channelize according to that, I think.
So guys, this was part 1 of the video. The part 2 will be released tomorrow, and if you are watching this video after a month or something, the part 2 is already out. You can go ahead and watch it in the Masters of Architecture playlist. So yeah, that's all for today. And if you like this video, go ahead, hit a like and subscribe to my channel. This will definitely help my channel to grow, plus this video to reach people who actually need to do this course. So go ahead, hit a like and support my channel. Thank you guys.